There are two basic kinds of flotation systems, the hand flotation system and the machine-assisted flotation. The hand flotation systems are inexpensive to make, but they result in less consistent recovery. That's highly dependent on the skill of the individual operator. Machine-assisted flotation systems cost more to make or to buy, but they help even out recovery rates among different operators. Nevertheless, in both systems, the operator needs to take meticulous care to achieve the best recovery rates. Both systems use a fine mesh screen in the bottom of a container to capture the heavy fraction. However, in a machine-assisted system, a spray of water shoots up against the bottom of the insert. Additionally, instead of scooping out the light fraction like you do in a hand flotation system, and which incidentally takes a great deal of skill, in a machine-assisted system, the light fraction decants into a very fine mesh of some sort, preferably a polyester cloth with sizing. With both systems, the light fraction is tied and hung to dry. Water screening is not the same at all as flotation. In flotation, the screen-bottom container starts out and remains underwater so that fragile remains, such as plant remains, suspend or float up gently. In water screening, water is used to screen material through a series of nested screens, ranging from 1/2 inch on the top to 1/4 inch to window screen, which has openings of 1 to 1.5 millimeters in size. So not only is the smallest screen size larger in water screening than it should be in flotation, but the process is far from gentle. In flotation, I prefer to use 0.8 millimeter mesh to capture the heavy fraction. I want to go through the hand flotation systems I have made and used, going through in chronological order. Now, although I first learned flotation on a machine-assisted system, the SMAP machine, at the Carlston Andesite in Kentucky with Patty Jo Watson, my first archaeological job in 1976 was to set up and run the flotation for the massive FAI 270 project in the American Bottom area in west central Illinois outside of St. Louis. I handmade the boxes, the wooden boxes that you see here, and the scoops. Now, the box on the left, you can see, has a very fine mesh because we were floating dirt from the American bottom, which is mostly silt and clay, and therefore I could use a 0.4 millimeter mesh and the dirt would pass through it. The regular sieves that you buy at the store, as you can see on the right, the top two, have too large a mesh, and instead I covered a large one with 0.4 millimeter mesh, as you see on the bottom scoop. So some considerations if you're making a system like this. The mesh in the bottom must be as small as possible and yet large enough to let through your largest dirt grains. I learned this the hard way. The wooden box eventually gets waterlogged, so you may need to place a concrete block or some other support inside your tank to help support the box when you're not swishing it back and forth. Both types of flotation systems, hand flotation systems and machine-assisted systems, require strong arms, hands, and thumbs, not to mention backs. I keep paperwork: who excavated the dirt, when, what's the provenience, the amount in liters in dirt, who floated it, who processed the heavy fraction, when they did that, and any problems. I prefer to have 2 tags written in the field per sample, an outside tag with heavy cotton string used to tie the bag shut, and an inside tag that you fold and wrap in aluminum foil and place on top of the dirt. This way, if it gets mixed in with the dirt, when you dump the dirt in the water, the tag is waterproofed and it pops up to the top, it floats. Both of these tags are important because they're used to temporarily label the light and heavy fractions after flotation. So here's the system I set up for the FAI 270 project. We were at an old loading dock, I don't know what you call it, but you can see that across the dirt road from us was another one that was still active. And we had a tank that we bought at the Goodwill store. And here Denise is pouring some dirt into a sample, and you see at the time the wooden box is still floating. Then you have to scoop. And this, as I said, takes a lot of skill. You need to not crush the charcoal that's up on the edges of the water in the box. So you keep your thumb kind of curled up and you rinse the dirt down in. And then as you scoop, one issue is how do you get all the dirt out of that? So you're moving the box back and forth at the same time that you're scooping. And then in this case, because we have ears on the sieve, we don't have to worry about getting charcoal all the way up to the edge, but you'll see in a later system where you have to make sure that there's a clear area at the far end of the sieve away from your hand. And here she whaps the ears on a piece of wood, flinging it onto newspaper. And back then in 1976, that's how we did it. Today I would use a polyester cloth. The heavy fraction also was put on a newspaper. Here she is popping it out. Potentially you could wash any remnant into the sieve and then also pop that back onto the newspaper. These can then be folded up into packets for later sorting. One nice thing about hand flotation systems is that you can do it in a stream like this, and here you can see the direction of the water flow and how it's taking away the dirt that's passing through. And obviously they're standing in a shallow area where they can rest it on the bottom. You could even do it in the ocean, and salt water has a higher specific gravity and will float more objects. However, you then would have to rinse out all that salt. The next system that I set up and ran was the incinerator system, so-called because the building behind me, as I'm standing here taking this picture, is the old county incinerator, now unused and empty, and a quite eerie building full of dead pigeons and leftover office stuff. And next to the railroad tracks and across the road from the county sewage treatment plant, which you can see at the far back right. And here we had access to a fire hydrant, and we had 2 horse tanks, and you can see I built several wooden float boxes. For this site, we processed over 3,000 samples, and back then we were using double plastic bags to hold them, not something that I recommend anymore. The problem with using plastic bags is that you have to open them up to let the dirt dry out. And in this case, then we had these pigeons flying around, so that created other problems. And then potentially if you were not in a building, you would have to close those up again each night. So it's best not to use plastic bags, which also are prone to tearing. I use 0.4 millimeter mesh in the sides of the box, but here is where I learned to use the 0.8 millimeter mesh in the bottom. I found out here at a site that has some sand, which is a large grain size, that sand does not pass through 0.4 millimeters, and yet most sand will pass through 0.8 millimeters. So I had 2 windows on either side that allowed the water to kind of swish through 0.4 millimeter, and on the bottom 0.8. And then on the scoop that I made there by wrapping a wire around a gallon milk jug, or a gallon, like a glass cider jug, and then wrapping it around a wooden dowel for a handle, I used a 0.8 millimeter mesh in that also, I think. Might have been 0.4. I can't remember. So obviously, when the box is still floating, or you've got I think I can see a concrete block underneath it, you pour in the dirt, you swish it around, you use the hose to rinse down the sides. Notice how my thumb is curled up. You can see how the charcoal is up along the sides of the box, and so you've got to rinse that down and make sure you don't squish it. So charcoal is pretty sturdy, but when it's wet, it's fragile and you can smush it. And then here are the steps in pulling out the light fraction. You dip in the sieve, you pull it up, and in doing so you need to try to keep the far end away from your thumb clear of charcoal, because then you've got to flap it on the piece of wood. And here we were using muslin, which I also don't recommend, but that's what we knew back then in the 70s. The heavy fraction you rinse down into a corner, and then I dump it also onto newspaper, and then potentially rinse out the last little bit onto I don't know what you call it, the sieve, and then that can be flapped back onto the newspaper with the rest of the heavy fraction. The heavy fractions were folded up and packaged in newspaper. There you can see one of the inside tags. And we labeled the outside of the papers. Many of these, the vast majority of these 3,000 plus samples are still waiting for the heavy fractions to be sorted. The light fractions were, at that time, put into glass baby food jars, which volunteers donated. And those actually are wonderful because they don't have static electricity, but they are breakable. I have this slide here to tell you two stories. You've probably heard at least one of these. As you can see, there's railroad tracks running behind me there. And day after day, the freight trains would go by, and the engineer is in the caboose. And one day, a train just started slowing down, until the caboose was right there, right behind my right shoulder. And he stopped. And as the engineer got out and he was climbing down that steep bank, he yelled out to me, "Lady, what the hell are you doing?" Because day after day, he'd been going by and seeing me washing dirt and hanging up these little bags, and he just couldn't stand the suspense anymore. And he knew exactly when to slow down his quarter-mile-long train so that his caboose stopped by me and he could walk out and find out what I was doing. We would have visitors also from the sewage treatment plant, during which I learned that the only two seeds that pass through sewage treatment and still sprout are marijuana and tomatoes. And sure enough, 1 year downstream from the outlet from the sewage treatment, the entire sandbank was covered in cherry tomatoes. And we thought, wow, all these free cherry tomatoes. We took grocery sacks down, we filled them up, and they were all tasteless. Anyway, the site itself was 1 mile down the road. I was over here usually working by myself or sometimes with helpers. And one day we invited all the site people over to flotation, and we bobbed for apples in the water tanks. They were clean. We also had a big pile of mud that we had to, from the shoveling out the bottoms of the tanks, and we had a tug of war so that the losing side got pulled into the mud. And then, kind of the most fun thing, we wrote this song that where you sing a line and then the audience has to repeat it, and we held hoses so that they had to repeat it or we would spray them, which of course on a hot summer day is not a bad thing, but it was a song about flotation. One of the next systems I set up as a wandering paleoethnobotanist for hire was at the site called Oreotimbo in Gujarat in western India, and I was working with the University of Pennsylvania. Here we had no access to running water. The closest water was at least half a mile away, so we used two 50-gallon drums. You can see that concrete blocks would be too short. We had these iron stands. The dirt comes in these metal containers called tagarun. And with no running water, I had a bucket of water and a little cup of water that I could pour to create kind of a stream. And then I had mesh in the bottom of a metal bucket. And so here are the women carrying the water on their heads barefoot through this thorny acacia shrub, and they got some horrible wounds stepping on the thorns, carrying the water over. And then here I am working. So I had two tanks because one would get kind of silty and dirty. And so while that dirt would settle in one tank, I would work in the other tank. But this is a hand flotation system, and my only kind of force of water is that little light blue cup of water that I could pour water and create a little stream. In this picture, you see the translator with his hand in the bucket. He did not normally help flotation. He just wanted to be in the picture. I also worked at Tel Janin with Birzeit University on the West Bank occupied Jordan. And here I am teaching a student to do flotation. And they already had this system. It's a barrel, hose, and then you see a stationary insert with those bars that stick out. And then the dirt would come in those rubber buckets. We were right here on top of the mound. This was a mound, and that's an olive grove. So again, I guess we did have a hose there, but we just used pouring water. And the director of this insisted that I didn't want to, I didn't think it was a good idea, but that I use his wife's hose to put over each over the sieve, as it were, and then you would turn that into an envelope and hang them up. But I didn't want to do it, and I don't recommend doing it, but that's what he wanted. Okay, now let me talk about machine-assisted flotation, starting with the earliest one, the one on which I learned, the SMAP machine. And this, I think, was the first machine-assisted flotation system. Because of the design of this machine, it required two people to operate. And here I am with Patty Jo Watson, So pretty amazing that the director of the excavation is so involved in recovery of plant remains and flotation that she herself spent hundreds of hours and days with me doing this. What made this design require two people is that there's a sleeve on the barrel, and then there's a short sleeve on the insert. But because of that sleeve on the barrel, you had to have two people to operate this system. Also, you see that they have a bucket with no bottom, and in the bucket are geological sieves for capturing the light fractions. This system required a pump, and my takeaway from using these pumps way back then in the 70s was that I hate pumps. They take constant care, they take a mechanic, you have to change the oil every day, they're noisy, they're heavy. In this case, with a river level that goes up and down, you can see Pat there with a little platform that she's made, and we had to constantly be moving it up and down. But we ran it all day long off, I think it was a 1.5 horsepower pump. We ran both water screening and flotation, and we had extra water to siphon away. But if you are using river water, you need to use a foot valve that has a fine mesh screen over the intake. So a foot valve keeps you from having to prime the pump each time you turn it off. And the intake must be upstream of the discharge so that you're not contaminating your samples. This is the SMAT machine, which was, already in use when I showed up, and they had been weighing their dirt, which I thought was a bit silly because the moisture would make it weigh more, and I was the one to institute measuring volume in liters rather than weighing the dirt. So here the water would run into these two geological sieves. I'm not sure why they had two. And then Pat was in charge of the light fraction. I was in charge of the heavy fraction. So here she is bopping the screen onto cloth to get out the light fraction, and then we could rinse out the last of it, and she hangs them up to dry. And I was in charge of the heavy fraction. On the right, there I am dumping some. This is a late archaic shell mound, so very large heavy fractions. I think on the left, I'm not actually emptying the heavy fraction. I'm cleaning the insert. So you have to clean the insert between each sample, whereas you don't have to clean the barrel until the dirt gets up to the shower head. So when you do clean the barrel, you have to take the bung out, and as I learned the hard way, you have to hang on to it. That force can be very hard, and if you lose the bung, then you got to go down, in this case, into this deep gully, which Pat, who as a graduate student grew up digging in Iraq, insisted on calling the Wadi. The Puce 1 machine was an improvement over the SMAT machine, and we made and used this at the site of Rojdi in Gujarat, Western India, again with the guy in the middle with the pink shirt, Greg Posel of University of Pennsylvania, and his co-director on the left from an Indian archaeologist. My little note here, everything backwards, refers to the fact that in India, welding was pretty cheap, but what cost money was newspaper and wood. So kind of backwards from here, where newspaper is usually free and wood doesn't cost much and welding is very expensive. We hooked into an irrigation system that was run on a single-stroke diesel engine. So that was very nice, and they made the barrel to my specifications. I carried the screen with me, the 0.8 millimeter screen. And we named it Puce 1 after somebody's son. I forget who's the driver's son. That was the driver's son. Greg knew a bit about piping and stuff, and so on the top left picture, you can see what he called the Christmas tree. And he made it so that when you undid all of that, you had practically nothing sticking out of the barrel, because anything sticking out would be a point of weakness where you'd have to redo the welding. And you see also that there's a little hose, and that the hose can be shut on or turned off independently of the water going into the barrel. We had a wash tub turned in. Thanks to problems in translation, we ended up with a little metal edge around the bottom that we didn't want, but that's what happens when you're trying to get a translator to say what you're saying, and they never want to do that. They just want to shorten it. Little wooden boxes. I had these wooden sticks with holes to help. Nowadays, I put just one on, and I like to tilt that box that captures the light fraction so that the light fraction hits the cloth and then kind of bounces out of the way from the stream of water. But by having the sleeve attached only to the insert that captures the heavy fraction and not to the barrel, one person can run this. So what a huge difference a small design difference makes. And if you're running into problems, something is jamming up, you need to stop, you simply tilt the sleeve up to stop the water from slowing out the sleeve. Also, the SMAP machine had a sloping bottom. And we discovered here you don't really need a sloping bottom. You can still get your dirt and stuff out. So that's one less bit of welding and weight. I know at the BMAP project, which I just realized I don't have any pictures here of that, we had a concrete slope in the bottom, so it made the barrel quite heavy. Now the insert there, inside the barrel are 4 welded rods that go across that support that insert. And underneath that was the shower head pointing up. Here's my entire setup. I was off the mound to the side by myself. And I frequently had large crowds, like, 100 people crowded up within 1 foot of me watching me all day. And at other times when there were no visitors who had walked, some of them 5 miles to come see an American woman. First, because I was by myself, they gathered around me. They didn't do that around the men up on the mound. They kept back. But when I didn't have a crowd visiting me, the women who worked for us, and we had 100 workers working for us, not all women, came over and used this just through the trees there as the toilet area, because in India, in traditional society there was no toilet paper. And that's what your left hand is for. So they want to wash their hand. So I had a very firm rule. No one was allowed to put their hand in the tank. They could only wash their hands, the water running out of the tank, because obviously I didn't want to work in that kind of water. So here you see a bunch of heavy fractions I've laid out. Again, cloth is inexpensive, so you use cloth to lay out. Those are heavy fractions, and hanging in the acacia tree there are some of the light fractions. So here I'm dumping in the dirt. The water, the charcoal, small plant remains, usually charred, float up to the surface. They come out the sleeve. They're captured in a polyester cloth with sizing that's kind of slippery. Here I'm rinsing down the sides to get it concentrated in the center. Then I tie it up into a bundle and tie it with the outside tag and hang it in a tree to dry. And then I wash the heavy fraction down to one side and dump it out. And then I'm using a fly swatter without the handle to get the rest of it out. And here you see the light fraction next to the heavy fraction. So they're both laid to dry. You see that the provenience number is written next to it, but you can see the outside tag, the inside tag, and rocks to weigh down the newspaper. So newspaper is used as a packaging, and that's why you had to buy it. It cost money. So I came back to South Carolina, and I went to the Coca-Cola distributing plant in Blackville or somewhere in northeastern South Carolina. For $5, I bought a resin Coca-Cola barrel. And using a Dremel saw, I made my own system called the Coca-Cola system. And here it is, 2 different years. The picture on the right was this past summer of 2019. Here I'm floating dirt from the Mulberry site, which is very high in clay. And so I have to pre-soak the samples in baking soda and water. And on the right picture, you can see on the board there 2 large packages of baking soda you can buy at Walmart, for example, for the pool. So now you can buy these big packages. I think they weigh 5 pounds each. And up on the little table next to the barrel, I have the sample that I'm going to do next. So you can see my insert over on the left. That was made by people at USC. I'm hanging light fractions on the right side on the fence. On the left side, I have a clothesline up. And so what I do is I start a sample soaking. This past year, we had to actually pound the dirt with the wooden stake, which you would think would break everything, but amazingly it didn't, to break up the very hard concrete type lumps. And then stir it and pound it. And then while that's soaking, I float the previous sample. So in other words, 15 to 20 minutes of soaking and as much baking soda as it takes. For most sites with some clay, it would take maybe 1/3 of a box, the small box of baking soda that you use in your kitchen. But here, you know, I just kept adding it as I needed to help break up those clay lumps. Okay, let me talk a minute about testing flotation recovery rates. When I was a traveling graduate student, I came up with this idea that you could test how well your flotation system was doing by burning some seeds, given that you're recovering burnt seeds, of the size that you hope to recover, but seeds that would never occur in your area. And so I started using poppy seeds, which are not native to Eastern North America. Now, I have to sort those under a microscope before I burn them, because any kind of seeds or anything, cereals that you buy at the grocery store, they all have stuff in them like insect parts. And USDA limits how many of those you can have, but you can have them, and other types of seeds. So I make sure they're all poppy seeds. I burn them, I count them out under the microscope, make sure, and I would add 100 seeds to samples. And the trick is, you have to add them to samples, and the person might know that they're having a test that day, or they don't know what day they're having a test. They don't know what samples have the seeds. And so I would have people come add them to my samples for me and tell me later which samples. But you keep it secret from the person doing flotation. This gives you a way to check whether you're contaminating samples. So let's say I added it to sample A and some seeds showed up in sample B. Well, that's not a good thing, but you want to know if that's happening. Also, if I added 100 seeds, how many seeds did I get back? And if I added 100 whole seeds, how many whole seeds did I get back? How many were broken? And so you see here some of my early work on the percent recovered by different flotation techniques. And so the incinerator hand tub that I was doing actually had pretty good recovery rates. You can see that the best were coming from the SMAP machine. The hand system, the I.1 in the river, you can see a great deal of variability. When they recruited people who didn't know much about it, didn't have quite as much training, that you could get some really bad recovery rates. And then somebody else, I think, tried it on the Pendleton froth, where they used air bubbles to help also pull up plant remains. So I didn't actually run that one. But it was a way to check, and people used it for some time, a way for me to tell people that using a machine-assisted system is a much better method that can help even out people who are a little sloppy. But basically, you don't want anybody sloppy. You don't want to send your worst people to flotation. You want to send your best people, because it's a huge investment in time and the cost that it costs to pay for the person to identify plant remains. And they need to take a lot of care. So just because you're doing flotation doesn't mean you're doing a good job. I wanted to throw in a slide here showing you some of the other materials that I use for flotation. One of the most recent finds that I was put onto are these Measure Right buckets that are marked in both gallons, as you see here on the left, and liters, which is what I use. And you can find these at the paint section at stores, and they come in these 5-gallon size and down to like, I think it's 3-gallon and then maybe 1 gallon, or anyway, there's 3 different size buckets. And then don't use plastic bags. They rip. And don't use solid bags, but instead the best to use are woven polyester bags. So there are more than one kind of sand in utility bags. You want the ones that are woven, and they come usually in packages of 25. Currently, they cost about 50 cents each, which is well worth it. You can potentially rinse it out and use it a second time if it's come out clean. And then after that, they make you put a little dirt in them and tie them shut, and they make great tarp weights. I don't use their strings for flotation, although I do use them when I make a tarp weight. Instead, I just ignore the strings and I tie it down a little closer to the dirt using a heavy cotton string strung onto kind of a luggage tag for the outside tag. The design of the barrel, I wanted to mention that is also very particular. It's really made for kind of a right-handed person. But you see there's the intake there on my Coca-Cola barrel with the Christmas tree. And then on the left, you can see perhaps the outtake and the drain. So directly where the sleeve comes out is the drain. And you want that at a right angle so that you stand there and work in between those two, the entry of the water and the exit. So you can reach down and turn the water on and off. You can see again the hoses run separately from the water coming into the barrel. Something else I learned that I didn't know when I made this, they now make plastic pipes that have brass fittings. And I didn't use this for this barrel. And this barrel is not plastic, it's resin. And so it creates a whole different set of issues in terms of gluing things to it and getting glue to stick and keeping it from leaking. But you certainly want to use the plastic, the kind of plastic that has brass ends, because it's very difficult to keep screwing and unscrewing hoses onto plastic without ruining the plastic. So you want the plastic fittings, that kind of plastic that has brass ends.